This is an Aeropress. Very simple device to make very tasty coffee, but it's also a great way to explain Ohm's law. What we're going to do to make a standard cup of coffee is we're going to take a filter, connect it to the cylinder, place it right here, add a little coffee, and then add some water. The coffee flows through the filter, and after you've let it steep for a little while, you should probably wait a little bit longer than this, but after you wait it steep for a while, you put the plunger on it. And you get a delicious cup of coffee. Now, why is this a great way to talk about Ohm's law? It's because we have current. The water that is in here and goes down here, becoming coffee in the process, is our current. Now, you can't see current in an electric circuit, so you can't see it flow. But here, you can. To make the current flow, we have to apply pressure to the top side. The pressure is your voltage. And the thing that keeps you from having infinite current flow is the filter. The filter is our resistor. So in Ohm's law, our voltage equals our current, the amount of flow, multiplied by the resistance. V equals IR. Let's take a look at some situations where we change the resistance. In my last cup of coffee, I used one filter. So I had fairly low resistance. But if I add multiple filters, I will get more resistance. That means that I'll have to push harder, creating more voltage, to get the same amount of current to flow. It's going to take me longer to fill up the cup. There's a few filters. Let's see what happens. And here comes the water. You'll notice that the current flow is slower than in the previous video. There's more barriers for that to go around. I also didn't put as much coffee in, so it doesn't look as tasty. In order to get the same flow rate now, because there's more resistance, I have to push harder to get it to flow at the same rate. Adding additional resistance reduces the current flow unless I increase the pressure on the top, unless I increase the voltage to make up for the increased resistance. So again, when we say V equals IR, the pressure that I'm pushing with has to go up in order to maintain the same current through the resistor. This time, I'm going to take a piece of plastic and use it to seal off the holes in the bottom of the filter. This will prevent water from flowing through. In electricity, we would call this an insulator. And it would have a very, very, very high resistance value. Sometimes we talk about it as an infinite resistance value. In this case, if V equaled I times R, because R is close to infinity, the amount of current flow will be close to zero no matter what voltage you put to it. We call this an open circuit. Let's add a filter just for fun. There we go. Let's see what happens now. What the heck? As you can see, I've added the water, but I have no current flow into the cup. This is an open circuit because no current is flowing. The resistance is too high. Gives me a nice chance to stir it and let it steep. You can try applying voltage to an open circuit. And in this case, I don't have a perfect insulator because a little bit's getting through, but in electricity, you usually have perfect insulators. And if you press hard enough, you can eventually make something break down, but I'm pressing pretty hard, and I don't want to damage the cup or have coffee go spraying out all over the kitchen. So I think I'm just going to say this pretty much, come on, you bugger, go, illustrates the concept of an insulator. It prevents current flow even under high voltage. Obviously, there's a breakdown point, and if I kept pressing harder and harder here, everything would blow apart, or I'd crush the cup, or something awful would happen. And you can get that with very, very high voltages too. Insulators do have their limit, but this is an open circuit with no current flow. Finally, let's take a look at the situation where I use no filter. With no filter in there, there will be no resistance to current flow. In electronics, we call this a short circuit. I put it on here, I add my coffee, looks like I'm all out of coffee now, and then I add my water. Even with very low pressure, you can see I get a massive amount of current flow because it just shoots right through. With no resistance to current flow, you basically get an infinite amount of current flow. V equals IR, with R being close to zero, I has to be exceptionally high for any given amount of voltage. So there you have it. The Aeropress is a demonstration of Ohm's law. We have the pressure generated by pushing down, representing the voltage. We have the current flow, represented by the water, going from the Aeropress into the cup. And we have the resistance, represented by the filter. When we have a plastic blocker in here, we have an insulator, and no matter how much pressure I put on this end, no matter what the voltage is, I don't get any current flow to speak of. When I have no resistance, doesn't matter, I don't even have to push on this, and I get lots of current flow. I don't need any voltage to generate a massive amount of current flow. The only time this works properly is when we have a filter in here. This is a resistor or a load on our circuit, and it allows us to do something useful with our electricity. Without the three components, voltage, current, and resistance, our circuits don't really do anything useful. We have either an open circuit with no current flow or a short circuit with essentially unlimited current flow. Resistors or loads in our circuit are critical to get manipulating electronic power. V equals IR. Ohm's law, and the power law, power equals current times voltage, are critical aspects to understanding how electronics works. It's difficult for people who are used to seeing physical things in real life when they're faced with electronics, and they don't get to see those things moving. But by using our test instruments and some simple analogies, we can start to understand how electricity behaves. Thank you to Science World for the mug. Fabulous place down there at the Dome. I'm not officially involved, and this is not a Science World video. I just needed a clear mug, and this was the geekiest one that I had. Thank you for watching, and remember, V equals IR.